Hi, this is Christoph speaking again, and welcome to the practical lecture on natural language processing. Normally, you already saw on YouTube the theoretical lecture on NLP. If you have not done so, do that first and then return to this workshop, because it will be pretty difficult to tag along if you don't have any notion of some of the theoretical constructs I talk about in the theoretical lecture. So sentiment analysis is what we will be doing today, and we will be doing it in Python. Where does this fit within the grander scheme of things within a digital methods course? Well, it's a good idea to watch this somewhere in April, somewhere around 20th of April after the data wrangling deadline. But of course, you can also watch it in March as well. But you should at least watch it if you postpone it near the end of April. It's also a workshop intended for everyone, so everyone should be able to understand the basic notions of sentiment analysis, and everyone should be able to do it in Python. And it's advisable that you already watch the theoretical lecture on NLP before watching this one, as I already mentioned. Now, let's do a short recap because I already talked about sentiment analysis in the theoretical lecture, but let's give it a more formal definition. Sentiment analysis is a branch of NLP which is all about analyzing opinions, sentiments, evaluations, attitudes, emotions towards entities such as products, services, organizations, issues, events, topics, and their attributes. It's a very broad definition as given by Liu Bing, someone who wrote a very good book on sentiment analysis, which is freely available online. If you click on the link in the PowerPoint, it will just get you there. So that is what we will be doing today. We will try to estimate whether a certain piece of text is rather negative or positive in emotional valence. It's also a very popular NLP application because it seems rather straightforward. It seems more simple to estimate whether a certain piece of text is negative or positive when you compare it to, let's say, detecting a certain news frame or detecting more complex constructs such as toxicity in a certain text. But there are two reasons that we should be critical of this enthusiasm, let's say, towards sentiment analysis. First, sentiment is or could be a very complex construct, but it's often reduced to a very simple polarity dimension from negative to positive. What do I mean by polarity dimension? Well, I mean that in most sentiment analysis modules or packages that are available, they give the text a score between -1 and 1, where -1 stands for a very negative text and 1 for a very, very positive text. But the question is this a good and valid translation of what Liu Bing calls opinions, sentiments, evaluations, appraisals, attitudes, and emotions? For example, a text that expresses a lot of anger is negative, and a text that expresses a lot of fear is negative as well. Both texts are negative, and many sentiment packages will give both texts just a negative score. But, as you might already know, an anxious versus angry text might have a very different effect on an audience. So it seems to make sense that you want to differentiate between those different types of emotions. Reason number two to be somewhat skeptical about sentiment analysis here is that it's not as simple as it looks. As we will see in the lecture here, is that a lot of estimations of these sentiment modules are not that valid, and they give some really strange scores to texts that are obviously negative. They will give it sometimes a very positive score, for example, and we will see why that is the case. There are a couple of ways you can do sentiment analysis. I already talked about lexicons versus supervised and unsupervised machine learning in a theoretical lecture. But let's do a short recap and apply it to sentiment analysis specifically. So when you do sentiment analysis with lexicons, you basically just count predefined words and their labels. In other words, you give the algorithm or the machine, the computer, a list of words that you have divided into two categories, positive or negative. Or you give it a specific polarity score, like I said, between -1 for very negative and 1 for very positive. For example, you could give the algorithm the idea that terrible is a very negative word, and you give it a score, let's say, of -0.8, which is a very negative score close to -1. So in this case, it's the humans that have to do the thinking, and it's just the algorithm that uses our knowledge about our language to estimate the sentiment of a text. But you could also do it with machine learning. In supervised learning, what you do is you give the algorithm a lot of example data. And this example data is labeled as being negative or positive. For example, we could give the algorithm 10,000 movie reviews or 10,000 Facebook posts that we labeled as negative or positive. And what the algorithm then will do is will define what kind of words or combination of words or combination and order of words are predictive for a certain label. So, for example, we hope that the algorithm will find out that terrible is predictive for a text document that we humans labeled as negative. So we don't feed any straightforward lexicon to the computer. The computer will find out that terrible is a word that often occurs in documents that we labeled as negative. But of course, the interactions that the supervised learning algorithm could, let's say, detect can be very complex. It can be a combination of words or even a combination and order of words. Third, you could also do sentiment analysis in theory with unsupervised machine learning, although it is very uncommon. In unsupervised machine learning, the algorithm will just look for patterns of words that are inherently present in the document. So you don't give the algorithm training data that is labeled. You just give it the raw text without the labels. And the algorithm will then look for words that tend to co-occur within the same text. And it's then up to the modeler to actually make an interpretation of the clusters of words that tend to co-occur with one another. This means that the modeler has to do a lot of work after the algorithm has actually been trained on the data. So, for example, the algorithm could find that terrible frequently co-occurs with other words in the same document that are negative as well. For example, words such as shameful or awful. And it's then up to the modeler to look at the different clusters of words that were defined by the algorithm and label them as negative or positive. This is not that common. Unsupervised learning is usually not applied in sentiment analysis. Supervised learning and lexicons are the rule. In this class, we will only take a look at the lexicon approach. In other words, we will take a list of words defined as positive or negative with a certain polarity score, and the algorithm will just count the words and make a prediction whether the text is positive or negative. Let's take a look at the two modules that we will use in this lecture. First, we will take a look at the pattern module. The pattern module is a straightforward lexicon approach developed by some people of the University of Antwerp, so it's developed in Belgium. Something which is pretty neat is that you can do sentiment analysis in Dutch with pattern, which is not that common. Most modules are made to analyze English language texts. Next to a polarity score between -1, very negative, and 1, very positive, it also gives you a subjectivity score. A subjectivity score in pattern is used to differentiate between texts that are factual or express opinion. And next to the sentiment analysis, pattern has also a ton of extra functionalities. For example, you can parse text with pattern and you can perform lemmatization with pattern. The second module we will take a look at is Vader. Vader is more complex than Pattern because it not only contains a list of words that are defined as positive or negative, it also contains some rules to make the estimations of the sentiment more valid. We will take a look at the specific rules later on in this lecture. It is developed by people of the Georgia Institute of Technology in the United States, and this is pretty interesting, it's specifically created to analyze social media texts. So text from Twitter, Facebook, YouTube comments, comments on websites, and so forth and so forth. I combined both of these modules in our sentiment analysis script. You can access the script simply by clicking on the link in the PowerPoint. Now, you might remember that in a theoretical lecture, I talked about some pre-processing steps that you usually do when you perform NLP analysis. And one of the first steps is that you tokenize your text. You extract the words out of the text, and you also do some part of speech tagging. You define which words are nouns, which words are verbs, and you also perform lemmatization. You bring the words back to their original form, their lemma. Now let's try to do that in REPL in Python. Before you do that, go to Euphoria and go to obviously a digital methods course. Go to practicals and then go to practical for NLP. And in the map examples and political speeches, click on that. Click on the PyProject file. It's the second file in the subfolder. Okay. Just copy the text you see here for a while. Oh, there you go. Okay, copy it. Now, go to your REPL and click on New REPL. Create a Python 2.7 environment, which is an old version of Python, and call it NLP Workshop Examples. And click on Create REPL. There you go. The first thing that you will do is you will create a new file and you will call it pyproject.toml. There you go. This file will define what kind of packages you need in your environment and most importantly, what kind of version you want of those modules or packages, whatever you call it. Now, copy paste the content of the PyProject file on Euphoria in the window in your file you just created in your REPL. There you go. Okay, you can see here that, for example, we need pandas, we need the pattern module, and we defined the appropriate version that we need for this analysis. Okay. Now let's actually do some parsing. So import pattern by saying from pattern.en import parse. So the pattern.en command will basically import the English language part of the pattern module, and the parser obviously will import the parser. Also import something else, namely the pprint function. It will be pretty evident later on why we will need this pprint function. Okay, so now we're set. Let's do some actual parsing. So create a new object called parseExample and call the function parse from the pattern package or module and feed it a sentence. So let's say I'm learning about sentiments analysis and I never had so much fun in my entire life. Okay. We also want the relations between the tokens or the words in our sentence. So give the relations options a true value. And we also want to do some lemmatization. So say lemmata equals true. Okay, there you go. Let's try this. Click on Run. It will first install all the necessary packages. And there we go. So let's call our object, right? Parse example. It will give you this. It's not readable at all. So let's try pprint parse example. So now we're calling our pprint, function of pattern here. And what it will do is it will take the same object, but it will print it in a nice data frame-like format. Okay, so now we can actually read it. You can see here that the parser successfully tokenized our text. So we have each word separately here. And in a second column, you can also see that it gave it the tokens the appropriate tag. So I is PRP, a pronoun. M is a verb of to be. Learning is also a verb. And sentiment and analysis are indicated by two N's, which are also nouns. Okay, that seems to be correct. You can also see in the last column, the lemma, that the parser successfully lemmatized all the tokens in our sentence. So I am becomes IB, and I'm learning becomes IB learn. Okay, good job. In the third column, you can identify the different chunks of the sentence. A chunk is a meaningful whole within a sentence. For example, let's take a look at so much fun. Take a look at the third column, and you can see that next to much and fun, there's a little hat. Okay, this little hat means that this word, this token, belongs to the previous word. The same goes for my entire life, right? So much fun and my entire life are chunks, meaningful symbolic units within a sentence that have not much meaning separately, but does have some meaning when they're combined. Okay, great. Now, do we have to do this pre-processing steps, this parsing, tokenization, when we do sentiment analysis? Well, no, we don't. Because whenever you're calling the function of your sentiment analysis module, the tokenization happens automatically. So for one thing, it's totally useless that you do that. But second, and more problematically, when you have a rule-based lexicon, like Vader, then your estimates of the sentiment in a text might be less valid. This is because a bag of words model doesn't care about the order of the words. Remember the theoretical lecture. So let's say that Vader has a rule incorporated in their lexicon that says whenever an emotional word is preceded by the word not, that you reverse the sentiment score of said word. If you incorporate this rule, then a sentence, the movie was not great, will have a negative polarity, and the movie was great will have a positive polarity, obviously. Now, if you just tokenize the words and create a bag of words model, then you remove all information when it comes to the order of words. And if you do that, well, then the estimation or the rule we just made up is totally useless, because the bag of words model doesn't know that the token not precedes the word great. So for this reason, the second reason also, we don't perform parsing when we do sentiment analysis with these modules. Now let's take a look at Vader. Vader wanted to give us a gold standard sentiment lexicon. This means that it is completely rated by human coders. It doesn't use some kind of machine learning algorithm, but it's just rated by volunteers on mTurk, which is a service on Amazon where you can hire basically workers, let's say, that in this case rate thousands and thousands of emotional valenced words. And it's specifically designed for short microblocks text like tweets, online comments, etc. In total, it has 7,500 features. It combines multiple well-established lexicons like the LIWC lexicon I talked about in the previous lecture, in the theoretical lecture. And next to that, it also adds some characteristics that are typical for microblocks, such as emoticons, like the heart shape emoticon will obviously have a positive sentiment. It also adds some acronyms and initialisms like LOL, WTF, and some slang words like nah, meh, and sucks, which is a misspelling of sucks with CKS, obviously. Also pretty prevalent within tweets, let's say, or Facebook posts. You can see a full list of features on GitHub. Just click on the link in the PowerPoint. Now, next to the 7,500 words that we feed to the algorithm with a certain polarity score, the Vader lexicon incorporated some rules to make some more valid estimates. The first rule takes into account the punctuation of a sentence or a text. So this is a great workshop with a couple of exclamation points after that. Will have a greater positive sentiment than the sentence, this is a great workshop, without any exclamation marks. Second rule is about capitalization. So this is a great workshop, capitalized, has a greater, more positive sentiment score than when great is not capitalized. Also something typical for microblocks text, online text, such as tweets, is that people are very expressive and they thus capitalize their emotive content. The third rule takes into account degree modifiers, so that the sentence, this is an extremely interesting workshop, is more positive than the sentence, this is an interesting workshop, as such. The fourth rule takes into account shift in tones. And it does that by just looking for the word but in a sentence. And whatever comes after the word but has a greater higher weight for the polarity score. So if you have the sentence, this is a great workshop, comma, but I just don't care about digital methods, whatever comes after but, so I just don't care about digital methods, will have a greater weight in the total polarity score, which means that instead of a neutral sentence, if you would just sum the negative versus positive sentiments, it will be a rather negative sentiment, because the person just doesn't care about digital methods. And finally, it also takes into account negated sentences, and it does that by checking the trigram preceding the word in the lexicon. What I mean by a trigram is simply the three words preceding a word that is incorporated into the lexicon. So, for example, in a sentence, this workshop isn't all that great, to be honest, the Vader lexicon will be able to reverse the polarity score of great, because it will check the three words before great. So, isn't all that will be checked, and the Vader sentiment analyzer will correctly predict that the sentiment is actually negative, isn't all that great, instead of positive. And this returns 4 scores: a negative score, a neutral score, positive score, which is basically a representation of the proportion of the text, which is negative, neutral, positive, and it will give you, and this is the most important score, a compound score, a general polarity score between -1 and 1, where -1 is very positive and very negative, and 1 is very positive. Okay, so let's try and test the Vader sentiment analysis package or module. So type in from Vader sentiment.vader sentiment import sentiment intensity analyzer. Okay, this will import our Vader module. Now what you will do is simply create an object that will call the sentiment function of our module. So this is like that, sentiment intensity analyzer. Okay, so this object, the sent object, will not do anything. It will just call the function sentiment intensity analyzer whenever we refer to sent object. And why we do that is just so that it's a sort of a shortcut, let's say, so we don't have to type in sentiment intensity analyzer each time we do a sentiment analysis. Okay, so sent object, and now we will actually feed it a sentence, or first we have to define a sentence. So let's say sentence that we want to analyze is when I was in class and the sentiment analysis just works, I was like, LOL, this is the craziest shit ever. And then do some expressive emoticons like that. Okay, so this looks like a typical text that you could encounter on Twitter or Facebook or in a chat box or whatever. Okay, now let's do the actual sentiment analysis. So we want to print something. We want to that it appears in the output. Print the sent object. So this will just call the function of the sentiment analyzer that we defined earlier, and then say, okay, I want the polarity scores of the sentence. So the sentence word here in this line here refers to the sentence we have just defined earlier about sentiment analysis in class. I was lol, this is the craziest shit ever. Okay, now let's see what that gives and click on run. Okay, so we immediately have an output. So negative 0.1, neutral 0.366, positive 0.517, and a compound score, so the overall polarity score of our sentence is 0.95, which is extremely positive. The maximum score again is 1, so a very positive sentence here. Okay. Now, let's take a look at the pattern package, the other package. The pattern package has a similar approach in the sense that it also wants to give us an intensity score. There's a polarity score between -1 and 1 of words, but it does that by combining manual coding with some semi-supervised machine learning techniques. So it doesn't give us a lexicon that is entirely rated by human coders, but they will define a small subset of words that are positive or negative just by hand, just manually. And then they will check what kind of other words tend to co-occur with these positive or negative words. And then whatever co-occurs, for example, with the word terrible, is most likely also a negative word, and they will add that to the lexicon. This is a good example of what I talked about in the theoretical lecture, how you can use one lexicon and create another lexicon, or in this case, a more elaborate lexicon with it. Now, it has 5,400 features, so 5,407 words. And more specifically, and this is pretty important, it only contains adjectives. So whatever you can place after this thing is or this person is, it is probably somewhere in the lexicon. So words such as this movie was great, terrible, awful, this person is, let's say, I don't know, evil, whatever. Those are the kind of adjectives that are present in the lexicon. It's not really a rule-based lexicon. It just counts polarity scores, and that's about it. It just counts the words, and it sums all the polarity scores between -1 and 1 and takes an average, right? And that's it. But there is one simple negation rule. So if an adjective is preceded with not or never, then it reverses the polarity score. So the sentence this movie is not great, it will recognize it as a negative sentence instead of a positive one. But it doesn't check the 3 preceding words like Vader does. So when we go back to our sentence of isn't all that great, Pattern will most likely rate it as positive, because the isn't is a couple of words before great. So this is a less complex negation rule than in the Vader module. It returns 2 scores, a polarity score and a subjectivity score. So the polarity score is just a sentiment, -1 very negative, 1 very positive, and a subjectivity score gives you an idea whether a certain text contains facts or opinions. And this is basically what I already told you. So they first rated some adjectives manually, 1,100 manually, and then they looked for words, or more specifically adjectives, that tend to co-occur with this small subset of negative or positive adjectives, and then whatever co-occurs with these adjectives, they added it to the lexicon. Okay, so let's try the pattern package now. Okay, or the sentiments in the pattern package anyway. So let's say from pattern.en import sentiments. Okay, so this will import our sentiments analyzer of the pattern package. Let's do away with this. Okay. Let's keep the same sentence here that we defined earlier and just say print sentiment sentence. So sentiment here, this will call the sentiment function of the pattern package. And you basically say, okay, I want to call the function sentiment and I want to feed it this sentence. And the sentence that you're feeding it with is obviously the sentence we defined earlier. Okay, so let's run it, see what it gives. Okay, that was fast. Okay, so the first score, I'm going to double check that to be sure. Yeah, the first score is a polarity score between -1 and 1. So 0.3 is a rather positive sentence. It's not as graded as positive as in the Vader package, which has had a score of 0.9 and then some, but still positive. And the second score here is the subjectivity score, which means, since it's 0.75, that the sentence is rather subjective. It gives rather an opinion of a person and not a fact. And this seems a rather correct estimate when you look at our sentence here. Okay, great. So now we figured out both packages, the Vader and the pattern packages. Okay, so the pattern and the Vader modules seem to do a good job. They have analyzed the sentiment in this one example sentence appropriately. And the question remains whether you can trust the results of these lexicons sufficiently. So let's compare these modules, libraries, whatever you want to call it, and look at pattern first. So what I want you to do now is go to Ufora again, and again go to the practical files, and more specifically practical 4 about NLP, and look for the file sentence examples. And this file contains 4 example sentences that we will analyze or in pattern. Okay, so click on sentence examples and download it. Now there are 2 ways to import this file into your REPL environment. The first way is pretty self-explanatory and straightforward approach. It's you can just click on upload file over here in your REPL environment and click on the file, where is it, downloads, wherever your file is. Okay, and you can click on the sentence examples file and it will be imported into your environment. That's the first way, but I will do it in another way, a less straightforward way. I will right-click on the sentence examples file and we'll just open it in Notepad++, but you can also open it without any issue in Notepad as well. And here you can see our 4 sentences, so this is basically the content of our CSV file. And then I will just copy it, Ctrl+C in Windows. And then I will click on Add File in REPL, and I will manually define the file, sentence examples.csv. Okay. And then I will paste it into the file, Ctrl+V. I'm just doing this because it's important that you are skilled in basically copying and pasting from and into your REPL environment as well, and not only rely on the upload file button here. Okay, so we have our first sentences here. Let's look at them. The first sentence is obviously the most positive one, and you already know this sentence. So I'm learning about sentiment analysis, and I never had so much fun in my entire life. Really positive. Second sentence is also positive, but not as positive as the first sentence. I'm really having a lot of fun learning about sentiment analysis in this digital methods workshop. Okay. The third sentence is kind of positive. It's neutral, slightly positive. I'm learning about sentiment analysis in this workshop, and I kind of like it, I guess. And the fourth couple of sentences, because these are 2 sentences, are clearly negative. This digital methods course is incredibly boring. I'd have much more fun drinking some good old duvels in the bar. Now you could argue that the second sentence here is positive, but it doesn't refer to reality because of I would. So I would have much fun here in a bar drinking duvels, but I'm being, incredibly bored in this workshop. So if the algorithm is sufficiently complex, it could incorporate a rule that takes into considerations these hypothetical indications in our language, such as I would. Okay, so hopefully Pattern does a good job of detecting the negativity in this piece of text. Okay. So let's see. The first thing we need to do is we need to import pandas. So type import pandas and say, or import it as PD. Now what this does is it first of all imports pandas, which is the basic and the most important data science module in Python, but you define it as PD. So whenever we want to call a function in pandas, we can just refer to PD. So this is basically just another shortcut, and that's about it. Okay, and pandas will allow us to import the CSV file into our REPL environment. So let's say we define an object that will contain our sentences, example data. And you type in PD. So again, we'll call a pandas function, and we call the function readCSV. And you will never guess it, readCSV is used to import CSV files into REPL or into Python. And then you feed it the file name, in this case sentence examples. Make sure that the file you enter here, the file name you enter here, corresponds with the file name you have entered into your REPL environment. And then you also make sure to tell the Python that your CSV file has no headers. So that means that our CSV file has no title, no column titles. And this is true, right? So if you go back to our example file here, these are just 4 sentences. It's not like there's a title here called, for example, sentences, right? That's not the case. So no header, just the sentences. There you go. Okay, let's see if that works or not. Okay. It does seem to work. There you go. Sorry, it's called, of course, example data. There you go. Example data should be our 4 sentences. Okay, right here. Okay, what you do now is you will create a series of sentences by extracting the first, but it's also the only column. You simply can do that by creating a new object, sentences, and you tell Python, I want the first column of my example data here. Okay. Remember that numbering in Python starts from 0, so that is pretty important to take into consideration. Okay, let's run that again. And then we have, again, our 4 sentences, but not anymore in a column. These are just a series of sentences. Okay, let's try to analyze or to put a sentiment polarity score to these 4 sentences with the pattern package. And let's be ambitious now and do that in a loop. So you tell to Python for sentence in sentences, do the following. So this means for each of these elements, for each of these sentences here, right, do the following. Print, let's say, the following sentence, and then you add a /n at the end, because this will create a new line. So you have some space between the different print operations. So for the following sentence, and then you print the sentence you're going to analyze. And then you say the polarity score according to pattern, that is, okay, again, provide some space. And then you say print, and then you call the pattern function for the sentiment analyzer, sentiment sentence. And this will just print out, again, the result of this piece of code, the sentiment of the sentence of pattern. And then you print, just to create some space between all these operations, 2 times a slash and a n. Okay, let's see what that does. And run it. There we go. So as you can see, it worked. Let's look at the first sentence here. So the very positive sentence has a positive polarity score of 0.1, which is rather positive, but not that positive at all, although it's clearly an extremely positive sentence. Never had so much fun in my entire life. Okay, then the second sentence, which is also positive but not that positive, has about the same sentiment score, so 0.16. Okay, strange. So it doesn't capture that nuance. The third sentence is neutral. Okay, that's kind of correct. Okay, we can see that. The fourth sentence has about the same polarity score, almost 0.1, as the other 2 positive sentences. Although it was very clear that this piece of text is very negative towards the situation of the person. He's incredibly bored right now. So as you can see, you can't always trust the, let's say the end result of these sentiment lexicons without checking them first. Let's see how the pattern package or module dealt with the last sentence here, because this is strange, right? That this negative piece of text has been rated as positive. So let's say, or type in your REPL environment print, and then again /n to create some space. Let's see how pattern handled the negative sentence. Okay. And then you give another loop command to Python, sorry, for word in sentiment sentences. And then you say, I want a fourth sentence. So again, the numbering in Python starts from 0. So sentences third element is actually the fourth sentence. So let's go back to our command line here. So if I do sentences 0, if it's still loaded into, there you go, I get my first sentence, you see. 1 second, 2, 3, and 4 will give me an error because there is no fifth sentence. Okay, I will clear this. There you go. So for our fourth sentence, a very negative sentence, give me the property assessments. You see? And for each of these words that you have assessed, so that you attach the polarity score onto, print that word. Okay. Let's try this one out and click on run. Okay, so near the bottom of our command line here, you can see what kind of chunks of the sentence or words of the sentence, tokens of the sentence, Pattern took to analyze a sentiment. So it took the word digital, it did nothing with it. Okay. And then it took incredibly boring. Okay, and it gave it a very negative score of -1. Okay, this seems correct. Then it took much more, and it gave it a positive score. And that's not valid because, well, I would have much more fun drinking, but it's not drinking, right? So this much more is not really positive in this context. And even in another context, much more doesn't necessarily mean that you are, saying something positive. Then fun, okay, positive word, true. Good, yeah, good old duvels, but you're not drinking them, so, but again, a positive score. And then old, also positive for some strange reason. Okay, so as you can see here, you can't trust these assessments without checking them as well. Now, how does Pattern calculate these scores? Well, it does just this. So it sums all the polarity scores. So -1, 0.5, 0.3, 0.7, 0.1. And then it just takes an average. So it has assessed 1, 2, 3, 4, 5, 6 pieces or chunks of the text. So you divide the sum of the polarity scores by 6 and you get 0.1. And that is indeed the score we get for our last negative sentence. Now, I did some other tests. You don't have to do them. I did them for you. I checked how the Vader versus Pattern modules react to those sentences. So, a couple of examples. Here I thought the first sentence here, I thought the movie would be awesome, but I've seen it a couple of days ago and it's not that good. The Pattern module thinks this is a very positive piece of text, while the Vader module incorrectly estimates that this is a negative text. And why is that? Well, as you can see, the Pattern just measures the words or checks the word awesome, probably good, and just sees that these two words are very positive, and thus the text is positive. But the Vader module, with its rule-based lexicon, checks the trigram preceding the word good. So it's not that good would be detected by the module as being negative. Also, the part of the sentence after but will have a greater weight in the Vader module, right? This is one of the other rules. So the "it's not that good" part of the sentence will have a greater weight than would be awesome. I thought the movie would be awesome. Okay, so the Vader does a better job here thanks to the rules incorporated in the module. Second sentence, I hate it when you do that. Both of the modules seem to think it's negative, which is true. The food was not bad at all, to be honest. Also, both packages rated as positive, although the Vader module sees it as somewhat more positive than the Pattern module. Then the fourth sentence, okay, I like the food, but the waiters were kind of rude. Again, same with the shift in tone rule that the Vader module has incorporated. The Vader module estimates it as negative, which is true, while Pattern estimates it as positive. I'm learning about sentiment analysis and I never had so much fun in my entire life, both positive, etc., etc. These are all the sentences that you have fed to the Pattern module. And you can see that even the Vader module gets stuck on the last sentence there, right? So the digital method score is incredibly boring, and I'd have much more fun drinking some good old booze in a bar. Even Vader thinks this is a very positive piece of text. So although Vader clearly provides a more realistic estimate, both modules have trouble dealing with multiple sentences. And doing the analysis on a sentence basis could be a solution, because if we split all texts or the last text in two sentences, then the Vader module will probably be able to detect that the first sentence is negative and the second is positive. But it is computationally rather intensive, especially on REPL. It's rather next to impossible to analyze a large amount of text sentence by sentence. So just keep this limitation in mind whenever you're analyzing longer texts, also for your exercises. For example, for the YouTube exercises, this is something to take into consideration for your protocol, for example. But these packages have trouble dealing with longer pieces of text, and Pattern overall does even a slightly worse job than Vader because of the lack of rules in the module. Now, let's use the custom-made sentiment function that I made for you guys. So I want you to go again to Euphora right here, and go to the sentiment analyzer part of the practical number 4 submodule. And you can download all files basically. You can just, if you go right over here, practicals, just download the entire, there you go, folder. This takes a while as usual. Okay, there we go. Okay, open it up and import it to wherever you want, right? I imported it to a folder right here. Okay, there are a couple of things I want you to do. So let's create a new REPL again. Do a Python 2.7 REPL and name it sentiment analyzer. Let's say package or whatever, doesn't matter. Create a new REPL in Python 2.7. Okay, great. Now what I want you to do is, again, go to the TOML file that you have downloaded, the PyProject Sentiment Analyzer TOML file. You can either import it, or this is something I will do. Open it up, right mouse click in Notepad, copy it, add a new file call it pyproject.toml. Oh, let's rename it. There you go. And paste it. Okay. So this will implement some new packages such as TQDM and the HTML parser. Okay. Now open up the Python file sentiment analyzer. Again, you can do what you want. You can upload it to your Python environment, REPL environment, but I will again open it up in Notepad, right mouse click, open in Notepad++ in my case. We can also open it in Notepad. I copy it and I paste it. Okay, there you have it. So what have you imported here? I created for you guys a custom function so you can do sentiment analysis without doing it manually. So imagine that you have 10,000 texts and you want to analyze them. You want to put a polarity score on these texts. Well, then you don't want to do that manually and write 10,000 lines of code, right? So this piece of the code, right? This is something that you can just use. This is a function you can just call, and you can feed it a CSV file and it will do all the work for you. Okay, now let's talk about the function for a while. Don't worry, I will try to keep it short and just talk about the basic steps taken in a function. So the first thing that I do is I define a function. I define a function called sentiment_df. And the function takes two values. The first one is an ID column. This will be a column that defines, for example, the person who is speaking or an ID of a text. For example, the ID of a comment on YouTube or the ID of a tweet. And then the second value is the actual column containing the texts that need to be analyzed for their sentiment. Then it prints out performing sentiment analysis. And then it creates 8 lists. Okay, so ID list, sentiment, pattern list, subjectivity, sentiment fader, neutral, negative, positive, language. Okay. And this means create a list. This is how you indicate a list in Python for all of these elements I listed here. Okay, now the fun begins. Then you say, okay, for each row in text column, and this is the text column you provide to the function here. This is the second value. For each of these rows or elements, do the following. And because TQDM here is a module in Python that will give you a progress bar. Okay, so whenever we loop through our rows, it will update the progress bar in our output. Okay, so for each of these rows, define an object named sentence. And the row here, what you do with that is you parse it with the HTML parser. Now, the HTML parser will delete, if that is necessary, some nasty HTML tags that might be contained in the text. And this is something that you will find from time to time in text taken from social media, for example. Okay, there are some tags that are not caught by the HTML parser, and these are the href tag and also the a tag. So this is the next thing we'll do. We'll replace the a tag, href attribute, and also the breaks manually. We will strip it from the sentence from our text. And then we will calculate the sentiment of the sentence, and we will save it in an object called send_pattern_sentence. Okay, we will do the same for the Vader module. So we calculate the sentiment with a Vader module with sentiment, intensity analyzer, polarity scores, and then what we analyze is a sentence, so the row of our text column again. Okay, so this is basically the material that you need to construct your data frame. And what you do then is you take some of these values and you add these values to the lists we defined earlier right over here. So you say to Python, okay, add to the sentiment pattern list the first element of the object sent pattern sentence. And remember that this object is just basically the end result of whatever pattern outputs as its sentiment score. And you may remember that the first value that the pattern module outputs is the sentiment score, right? So again, Python or counting in Python starts with 0. So we want the first value of this object, okay? Then we do the same for the subjectivity score. It's the second value, so it's value number 1. And we do the same for the sentiment Vader list. So we take whatever the output is of the Vader package, and we ask for the values, and we want the fourth value. This is the general compound score, remember, between -1 and 1. And we do the same for the negativity score in the text, the neutral score, and the positivity score. So the proportion of the text which is negative, neutral, positive according to the Vader module. And then there is one thing we want to do as well. We want to define the language in the text. But before we can do that, we need to remove some emoticons or emojis from our text. And this is something that you have to do, for example, in social media text, as in, for example, YouTube comments or Facebook comments and tweets. You want to delete the emojis because these can, these can confuse, let's say, the algorithm that detects the language in your text. And what we say here, we define basically the codes that represent emojis. These are some general universal codes. And if you translate these codes, in Unicode you get emojis. And we say, okay, we want to define a clean sentence. And this clean sentence is basically defined by taking the emoji pattern, thus the smileys we defined here, and replace them in the sentence in the row of our text column, so in the text file. Okay, if you've done that, try to add something to the language list. And what we will append to the language list is this piece of code. And what this does is it detects the language in our piece of text. And if this doesn't work, for example, if a comment only contains emojis, so it is unable to detect language in any way, well, if there's an error, just append to the language list no features in text instead of the language it can detect in that case. Okay, if you have done that, then define an output file, which is pandas. Remember, pandas, we define it as PD, this pandas data frame, with these columns, ID, sentiment pattern, subjectivity pattern, and so forth. And these columns, fill them with these lists. ID column, sentiment pattern list, subjectivity list, sentiment Vader list, and so forth. Remember, these are the lists that we constantly are filling as we are looping throughout all the rows of our data frame. And then if you've done that, just display or print done and return to us the output. So whenever you're defining a function, you need to tell the function what it has to return to the Python environment. And in this case, we want the output object, and the output object again is our data frame containing the IDs and all the scores, sentiment scores of our texts. Okay, So this is something you don't need to worry about for the remainder of this course, because you can just use this function as it is. And you can use this function by just calling the function right here. So sentiment_df, and then filling in an ID column and a text column. And I did just that for you. Let's say I have in the files you downloaded from Ufora, you have a CSV file called YouTube Comments small sample. Okay, I want you to upload this file into your REPL environment. This time I will just upload a file directly into the environment. Let's say, oh, where is it? Practical, files on Ufora, sentiment analyzer, YouTube comments, small. Okay, let's see what this file contains. As you can see, these are a lot of text files. These are more specifically around 1,000 YouTube comments. You can see the smileys, the abundance of smileys in these YouTube comments. And I have one ID column. Yes, you can see the ID of the comment here, which is unique for each and every comment, and a text column, which contains all text of the comment itself. You can see a lot of nasty formatting issues here. For example, you have the A tag here, you have some breaks here, you have some weird translation. This is because the UTF-8 translation has some issues. So this is why the HTML parser and the substitution of the A tag and all that, and the href attribute, as you can see in this example, is necessary to include in our function. Okay, so let's feed this CSV file to our function here. First, load the data. As you can see here, I already prepared a template for you. So loading data into environment, and then you define an object sentences. Again, you read the CSV, and I have a template says sentences.csv, but this file is not called like that. It's called YouTube comments small sample. So fill that in the script. Encoding is UTF-8. This will replace some of these weird signs over here. And the separator is semicolon. This is a really important one. So whenever you have an error in your import, always check that the separator is defined appropriately. And this seems to be the case. If you go back to our file, you can see that the semicolon separates each and every column. Okay. Then you have to perform the sentiment analysis. So we define an object sentiment result. And then we actually use our function here. So we call the sentiment_df, which is again the function we defined here. And we need to feed it, remember, first a column that contains the IDs of a text, and then the text column itself containing the text. Okay, so sentiment_df, the ID column, and the sentences, and the text column, excuse me. So this is how you define or extract a column, specific column in Pandas. You just name the data frame that you loaded into Python, and in this case, this is sentences here, remember. And then you just type in the name of the column. And this is, as you can see here in the CSV file itself, the ID column is called ID, which makes sense. And the text column is just called text. There you go. You see? And then after performing the function, you write your result, the sentiment result. So this object here, you write it to CSV. And you call it sentiment.csv. Again, encoding it in UTF-8, separate it with a semicolon. Again, all the all the columns. And this is pretty important, you define the decimal, so all numbers or decimal numbers with a comma. So numbers are not displayed as such, which is the default in Python, but as such, which is a default in, for example, Excel. So this is a good idea if you want to do anything with these polarity scores in Excel. Okay, let's see. Let's try and run this. YouTube comments. Let's double check our name here. YouTube comments, small sample CSV. Okay, this seems correct. Okay, let's click on run. Of course, REPL has to install all the modules first. This takes a while. Okay, it seems to work. As you can see, it goes through all the rows, all the texts. Bum, ba-dum, bum, bum. There you go. And as you can see now, there's another CSV file outputted in your REPL environment, which contains all the polarity scores. So now that we have our sentiment file and thus all our scores of all our YouTube comments, we can save this file into CSV. You could, of course, click here and download the entire environment as a zip file, but you could also just Control A in Windows, Control C, and copy it into, let's say, a simple notepad like this. There you go. Okay, and then you can save it as let's go to desktop and save it as sentiment workshop, or no, let's say YouTube comment sent, and call it CSV file. There you go. Okay, how do you open this file? How do you do anything with it? Well, let's go to Excel. Open Excel. There you go. And go to Data over here. And then click on Data from Text. And go to your file you just saved as a CSV. Here, YouTube comments sent. There you go. And you get a text import wizard here. I'm pretty sure that Frederik already explained to you how you should import comma-separated values into Excel, but let's just do a recap here. So again, select UTF-8 as encoding. It's a delimited separator, and the separator is a semicolon, as you can see right over here. Semicolon. There you go. We don't need to treat text variables, right? So we don't need these quote characters. This is exactly the reason why I'm just saving the ID of the text file and not the text or the comment itself, because this always results in some trouble if there are a lot of commas or semicolons or quote characters in the comment itself. So we don't need that. Just delimiter semicolon, next, finish. Okay. Now you can delete the first column if you want. This is just the index as provided by Python. Okay, there you have it. So these are the IDs of all the separate comments. Then you have the first column, sentiment pattern. Remember, this is basically the list we filled row by row with our function. And the same goes for all the other columns. Subjectivity pattern. There you go. etc., etc. Sentiment fader, neutral, negative, positive, and then the language. Now the language detection isn't perfect, but it's better than nothing, basically. I believe that the module I'll use here for the language detection is trained on Wikipedia. So it takes the different Wikipedia pages in English, in Dutch, in Spanish, and whatever, and it constructs a dictionary from these Wikipedia pages. And then estimates the probability that a certain text is in English or in Dutch or in whatever, in French, etc. Okay, so let's look at a very positive comment. So sentiment fader. And let's look at a random positive comment here. You have a very positive score on the sentiment fader column. Okay, let's copy the comment here and open up. Let's open up our YouTube comments. Oh, excuse me. Hold on. Yes, let's open up our YouTube comments. There you go. Okay. Let's search for these comments. So click on the A column and then search. It's Control F in Windows, and then paste the ID of the comment here. Okay, this is obviously, we have selected a spam comment by accident, I guess. So, reunite ex-lovers after being dumped and stops divorce. Get promotion you have desired for a long time at work or in your career. Ensure success in work and business. Get luck and in winning big in any lottery. Okay. So, okay, this is a bullshit comment. But from an objective standpoint, it is a very positive piece of text. It's about a good spirit, good health, etc. So maybe we should also incorporate a spam detector in our function. That would be great. And for example, using supervised learning, feed an algorithm 10,000 YouTube comments divided into 5,000 non-spam and 5,000 spam comments, and so that it could predict whether a comment is spam or not. But anyway, it seems to do a good job in an objective kind of way. And what you need to do then in the data wrangling phase is basically join this column with this column, or whatever column, or data frame, or whatever other data frames you want to join, right? But if you want everything in one data frame, if you want here the sentiment fader values, etc., then you need to do a join, right? This is something that Frederik will talk about in one of his video lectures in Power BI as well. Now there are some comments I want to make on the function here. So first of all, if you want to analyze, let's say, more than 8,000 pieces of texts, even if they're not that large or long, then REPL will get in some trouble. So this is perfectly feasible with this function on your own computer. For example, if you use an IDE such as PyCharm I use here, you can do it on your own computer without any trouble. But REPL will probably crash. It just can't handle these large amount of data. So if you have more than 8,000 YouTube comments, let's say, you have to split up your file and do it in multiple goes. Okay, so you have to import multiple files here, and then one by one import a file, and then give the appropriate CSV file, do the encoding, run the function, copy paste the output into Notepad, again like this, and then do it with the second subset of comments, with the third, the fourth, etc. And each and every time run the function by defining the appropriate CSV file and copy paste the output in Notepad. And then in the end, when you have done all the or analyzed all the subsets of the comments, you can just save the Notepad file with all your comments. Okay, I think that's about it. We basically have gone through all these slides. You can check them by yourselves if you're stuck or anything, or if you want to read about it instead of me talking about it. So this is again the function. We already saw that function. This is how you load data. Yes, we did that. Yes, we imported it into Excel. Yes, and we already have seen the end result in Excel as well. And then some errors, already talked about that. Okay, so that's about it when it comes to the official part, let's say, of the sentiment workshop. I will create one extra video where I will talk about a case study. It's a pretty interesting case study. I will analyze speeches of US presidents, and I will use the Vader sentiment module to do that. And I will check how the US presidents used emotions throughout their speech, and whether you can see some sort of progression in emotional valence throughout the speech. And in the end of this video, you will know how you can get to this kind of graph. Let's see. Okay. So this is something I will create in the next video. It is not mandatory, so if you had enough of me, then you can just ignore that video, which is fine. But I do hope that you're interested in sentiment analysis and in this case study of speeches of US presidents. So I hope I'll see you there. Bye now.